This is lesson 16 for 8th grade, and today we talked about irrational numbers. Now in the past we've been talking about rational numbers. Okay? Now rational numbers, remember, I would always highlight or underline the word ratio. Basically any number that can be written as a fraction. These could be negatives, it could be 0, it could be any whole number or any fraction. So a bunch of examples here. Basically this covers all these different types of numbers. Integers, which are your positive, all your positive numbers plus 0 and all their opposites. So anything from negative, red is set here, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay? So, rational numbers, they include the integers, all your positive whole numbers plus 0 and all the opposites. So it includes all the integers. It also includes all your fractions, whether they be positive or negative fractions, but, well, I'll just say all fractions. So, it can be written as a fraction, it can be written as a negative fraction, it can be a negative whole number, well, it wouldn't be a whole number, but an integer, it could be a negative number, it could be positive. Basically all your nice numbers, so we could have 1/2, 2/3, 17/20. Even improper fractions are okay. 20/19, 24/3. You know, that comes out to be 8. That's still okay. All those things. Even square roots. Let's say 4. If it comes out to be a whole number, it's still irrational, because that's 2. Square root of 9, that would all be included. Okay? Since it's 3. Basically anything that comes out to a whole number or a fraction, we would consider a rational number. Now, I'm going to erase all this. And then we're going to talk about what an irrational number is. Now these are a little funky. Alright. The set of rational numbers is closed under addition, subtraction, multiplication, and division. That means you can add, subtract, multiply, or divide any rational number and you can still get another rational. Says, however, the square roots of many rational numbers, such as square root of 2 and square root of 3, are not rational numbers. Let's see, it says, since square root of 2 and square root of 3 are greater than square root of 1 and less than square root of 4, their values are more than 1 and less than 2. To kind of sum that up, square root of 1, we know that's 1. Square root of 4, we know that that's 2. We talked about that last week. That means that since all these go in order here, square root of 1, square root of 2, square root of 3, square root of 4, these two have to fall in between 1 and 2 somewhere. But we know that there aren't two numbers, at least two numbers that we know, to multiply once to get to get 2, or two numbers that we multiply, or one number we multiply once, twice to get 3. So here, square root of 4 is 2, because 2 times 2 is 4. Well, it's not very easy to figure that out for square root of 2, square root of 3. To find the approximate value of these, we use a calculator with our square root button. Now approximate, that means it will round. It won't be, because like I said, these numbers, you'll get a decimal, and that decimal will extend forever, and it'll be very random. There is no repeated pattern or anything like that. Like a fraction. 2/3, that has a pattern. It's 0.6666, keeps going on forever. 6s, all the way into infinity. Other fractions like 1/2, that's just 0.5. That one stops. So we have terminating decimal, or non-terminating decimal. That would have a pattern. Those are your rational numbers. These irrational numbers don't have any rhyme or reason to them. they just have a bunch of random numbers as decimals, so we have to write them in ways like this. And it's very easy to spot an irrational number because trying to figure out the square root of 2 or the square root of 3, if you can't figure it out and you don't get a whole number answer, it's going to be irrational. Alright? So, if we look at this group here, we want to figure out which one of these numbers is irrational. Okay? So basically we're going to look for the one that we can't find the square root of. Okay? Square root of 0. That is actually 0, since 0 times 0 equals 0. Square root of 4, that's 2, we know that one, since 2 times 2 equals 4. Remember square roots, that have a little 2 here. If it's not shown as a little 2. And we're looking for one number to multiply twice, we get 4. So that's why it's 2 there. Let's skip over to D here. We know this one is 4, since 4 times 4 equals 16. Square root of 8. A lot of my students wanted to say that this was 4, but it is not 4. Square root of 16 is 4. This is irrational. This is our irrational number. Because we can't find the square root of that without a calculator. Or I haven't, well, there is a way to simplify that answer. We have not gotten into that yet, but we will later this year. There is a way to simplify this into a better irrational number, but this, for now, we would put it into our calculator and look at it and say, okay, that's we're going to get a decimal there, and we won't get a whole number answered. So that is our irrational number. Remember, the ones that are strange or a little off. The most popular irrational number would have to be pi. That's where we usually approximate that to 3.14. Pi goes on forever with no rhyme or reason. That's probably, that's the most popular irrational number, would be my guess. Okay. So now, if we combine our rationals with our irrationals, we get the set of real numbers. And here's an example of a bunch of real numbers. So now we've basically talked about every type of number we're going to deal with this year. All the real numbers. There is such a thing as an imaginary number or a complex number. We haven't gotten to those yet. That's more so algebra. That'll be next year for a lot of these kids. But yes, real numbers. Okay, they're real. You can work with them in the real world. Okay, I'm going to check my time quick here. We're doing fine, we're doing fine. We've got 2 examples to get through here. Okay, this one right here, we want to arrange these numbers from least to greatest. How would we go about doing that? Well, we could turn all the ones like square root of 5 and 5 over 9, we could turn those into decimals, we could do that. Which I would recommend doing, actually. But here's one way we could get around it. Let's say we didn't have a calculator with us. I know that this is over 1/2, and I also know that that is a decimal, just myself, I can remember this, is 0.555555, repeating, keeps going on forever. But what we really want to focus on is the square root of 5 here. Square root of 5, let's say we didn't have a calculator. Well, square root of 5, what are 2 numbers above and below it that we do know the square root of? Let's say square root of 4. We know that's 2. That equals 2. The next one that we know the square root of 9. That's 3. So, square root of 4, square root of 9, I know that the square root of 5 has to be in between these 2. So I know that the square root of 5 is between 2 and 3. So that one's between 2 and 3. So if you did type that into your calculator, you're going to get a decimal answer. It'll be 2 point something. And it'll repeat, or keep going on. There won't be any pattern to it. and your calculator will probably approximate it. It'll be like 2 point something. Alright? So, now that we know that, we can start. 0 will be our smallest because none of these are negative. Looks like our next one will be 5/9 because it's less than 1. So 5/9. And 1 would be our next number. 1.2, looks like that's next. And after that, this is between 2 and 3, so we want to list 2 first. Then square root of 5. And then 3. I think that covers all of them right there. So that would be the correct order there, okay? Once again, if you don't have a calculator, figure out what that's going to be in between. If you do have a calculator, go ahead and find that decimal. Alright? Our last one here. Check my time real quick again, just want to make sure. Okay, plenty of time, that's what I thought. Now, this is how we really want to think about how to solve for something a little bit outside of the box here. The area of this square is 2 centimeters squared. What is the length of each side? Okay, first thing we know, this is a square. And we're dealing with area. What should have gave that away is our units are squared, but they also said that we're dealing with area. So, I know the area of this thing is 2 centimeters squared. Now, area for squares, that's our formula, excuse me. You take your side and you square it, or you multiply s times s, side times side, that'll give you your area. So we're looking for the s, basically. What is the side length of that square? Might not be so obvious. Here's what we do know. We know that 2 equals the side squared. Okay? Now, as I was talking before in a previous lesson, we have inverses to help us solve for these variables here. Remember that adding and subtracting, they're inverses or opposites. We use those to solve for one another. Multiplying and dividing, they are opposites. Well, the opposites here, which we just started talking about on our last lesson, was that square roots and squaring are opposites. So that would be, let's say we had 3 squared. Well, let's do, basically taking the square root is how you would solve for something being squared, and vice versa. So if you're solving for something inside of a square root, you would square it to get your answer. Here's a little different, and I'll show you an example. It probably sounds a little confusing right now. Let's pretend that our square was 4 centimeters squared, and we wanted to find the side length. Well, I know that this has to be the same side, so we know that it's going to be 2 and 2, because 2 times 2 gives us 4. It's the same thing as saying, okay, here's our area, 4 equals s squared. It's the same thing as taking the square root of both sides. So we know that 2 equals our side. So it would be 2 centimeters there. Okay? Now that's not what we're doing over here. Well, it is what we're doing, but we don't have as obvious of an answer. So what we're going to do here, I see a squared, and I want to solve for just one s, not the squared s. I'm going to take the square root of both sides. And what we'll get is square root of 2 equals s. We get an irrational answer. So the only problem with working with these irrational numbers is now that we can get these for answers. That's okay. This doesn't look like a typical answer to write, but that's what it is. So the side length of this square is the square root of 2 centimeters long. That's how we go through that. My guess is we'll have to work on some of this again tomorrow, but this was lesson 16 for 8th grade. The homework should be on the link tonight. I'll try to get that out there now.